For this example, we want to use the given mesh and constrained loops to write equations for this circuit from which I can find the current I, the current in this direction through this 10 ohm resistor. I have three mesh currents, I1, I2, and I3. So I'm going to end up with three mesh equations in three unknowns. Then I'll have another equation from which I can determine I in terms of the mesh currents. That'll give me a total of four equations and four unknowns. Let's loop around I1 first. Now when I'm following I1, I'm going to set my sign convention such that I1 enters positive voltage terminals. So going through the source, I see a negative term first on the 10 volt source, so that's a negative 10 volts. Then the voltage across the 10 ohm resistor, with this being the positive terminal, is the resistance 10 ohms times the current through the resistor, with this being the assumed positive direction. I1 is entering the positive terminal, so that's a positive contribution. I2 is entering the negative terminal, so I subtract that off. And the 2 amp constrained loop is also entering the positive terminal, so I add 2 amps. Next, I go through the 12 ohm resistor. This will be my sign convention. The mesh current that I'm following will enter the positive terminal. So the resistance is 12 ohms times the sum of the mesh currents through that resistor. The only one going through that resistor is I1, so that sums to 0. Now loop I2. When I'm looping through I2, I'm going to go ahead and forget the sign conventions that I used when I did loop I1. Now I'm going to set my sign conventions according to the direction of I2. So if I start down here in the 15 ohm resistor, I'm going to assume that this is the positive terminal because then I2 is entering the positive terminal. So I get 15 ohms times I2 is a positive term. The 2 amp constrained loop is entering the negative terminal, so I subtract that off. The next resistor I pass through is the 6 ohm resistor. I'm going to set up its sign convention according to the direction of I2, so this becomes 6 ohms times the only mesh current going through that resistor is I2. Next, I pass through the 8 ohm resistor. Again, I'm going to set my voltage sign convention such that I2 enters the positive terminal. So this becomes 8 ohms times I2, and I3 is now entering the negative terminal, so I3 is a negative contribution. Finally, the 10 ohm resistor, I'm going to use a voltage sign convention such that I2 enters the positive terminal. This becomes 10 ohms times I2. I1 enters the negative terminal, so that's a negative contribution, and the 2 amp constrained loop enters the negative terminal. That becomes a negative 2 amps. This sums to 0 because I'm back to my starting point. Loop I3. Again, I'm going to ignore the sign conventions that I set up previously. I get to reset those every time I do KVL. So on I3, if I start down here, I'll set up my voltage sign convention so that I3 is entering the positive terminal on the 8 ohm resistor. So its voltage is 8 ohms times I3. The other mesh current going through the 8 ohm resistor is I2. It is now entering the negative terminal. That becomes a negative contribution. Through the 20 ohm resistor, I'm going to set up my sign convention such that I3 is entering the positive terminal. That becomes plus 20 ohms, and I3 is a positive contribution. That brings me back to my starting point, so those sum to 0. Now I have three equations and three unknowns. I can solve those for I1, I2, and I3. The last thing I need to do is write an equation for the current I in its assumed sign convention, so I can find I in terms of I1, I2, and I3. The current through any element is the sum of the mesh currents passing through that element. So I is equal to the negative of I1, because I1 is going in the opposite direction from I, plus I2. I2 is going in the same direction as I, and the 2 amp constrained current is going in the opposite direction from I, so it's got a negative sign. Those are my equations. They can be solved for the current I.